Welcome back. In this section, we will take a deep dive into AWS EC2 resources. We'll understand the architectural capabilities of this service. We'll understand how to use this service when in terms of the performance of the application, the scalability of our application, how to make our application highly available, and how to secure our applications. What are the security tools and resources AWS provides us when we are using AWS services. We want to understand how the monitoring works with AWS services. We look at the pricing model for EC2 services. We looked at the pricing model briefly in the previous section. Now we want to take a deeper dive and understand the different pricing models that are available for us. We'll also look at the interfaces, how we can interact with your EC2 services, how we can start those EC2 services. So in the previous section, we learned about different types of EC2 instances. We learned about compute optimized instances. So if your application is a high performing application that requires higher CPU capacity, then we choose to use highly compute optimized instances. If you already have an instance that's launched, let's say you use different instance type, and then you want to increase the performance, this instance is not able to keep up with the compute capacity, compute requirements for your application. In that case, you have to stop that instance, change the instance type, and relaunch it. Okay, this is the elastic part of the EC2 instance types. Okay. We learned about GPU optimized instances. So if your application requires access to the GPUs or the graphic processing of instances, or if you have highly graphic intensive applications, compute workloads like video editing and processing, financial modeling, then you would want to choose the GPU optimized instances. If you have a lot of storage requirements, your application requires highly dense or lot of local storage. In that case, you would want to use storage optimized instances. Okay. These instances typically come with SSD, high performing SSD disks. Okay. And if your applications are, for instance, they are using NoSQL databases like Cassandra and MongoDB, this is great use case for those types of applications. On the other hand, if you have lot of storage requirements for your applications, your application requires a lot of local storage for parallel processing or Hadoop jobs, and you can have distributed file systems that your applications may be running, a lot of log processing, number crunching. So for that use case, the dense storage optimized instances are a good use case for those. The other type of instances or performance benefit that we can leverage is called EBS optimized. Okay. EBS optimized in a sense provides a dedicated throughput between the EC2 instances and EBS. So they provide a dedicated network between your EC2 instances and the storage volumes. Okay. So that minimizes the contention between our EBS volumes and other traffic that may be coming into your EC2 instances. So these are great and highly recommended for database services. So those types of instances are called EBS optimized instances. If you want to have enhanced networking support, so that means you need to have low latency networking between your instances. You want to have high number of packets that go between your instances. Then you would want to choose enhanced networking support. Okay. So there are a couple of prerequisites before you start using enhanced networking instances. The first is you need to make sure you're using an HVM AVM, the hardware assisted virtual machine virtualization instances. And there's a driver that you need to install before you enable enhanced networking for your instances. There are drivers available both for Linux and Windows instances, so you can leverage that option. There is no additional fee for using enhanced networking support in EC2s. Next, let's talk about scalability. So in scalability, there are generally the two different ways we can scale or increase the performance or capacity of our instances. The first is the vertical scaling. So this one, like we talked in the previous slide, we can change the instance type. We can grow from a large to an extra large, or we can get more CPU, get more memory by just changing the instance type. And this one requires stopping that instance, changing the instance type, and restarting that instance. Okay. If you want to do horizontal scaling, which is highly recommended in cloud environment, is you want to launch several of those instances instead of one or two instances. Then you can grow horizontally by adding more instances of the same kind. The other type of scaling we mentioned briefly in the previous section is the auto scaling. Auto scaling is an Amazon feature, EC2 feature, that allows us to grow our capacity, grow our compute capacity based on certain conditions that are occurring in our environment. So in case, let's say you have more traffic coming into your network, your CPU goes up, your network traffic your instances are seeing a lot of network traffic. Based on any of the conditions that you specify, Amazon EC2 adds capacity to your infrastructure on those when those conditions are met. Okay. It's very well suited for applications that experience variability in usage. So if your application requires more resources during the weekdays than weekends, auto scaling is very well suited for those applications. The other service that Amazon provides for scalability is the elastic load balancers, or ELB. When you're using a load balancer, it distributes the incoming traffic between multiple EC2 instances. Okay. And these EC2 instances are typically set up in a different availability zone. You can set them all in one single AZ if you choose to, but the best practice is to spread it across multiple availability zone. So the load balancer helps us design what we call fault tolerance in our application. And one of the benefit of ELB is it detects any unhealthy instances within our application pool. And if one of the instances fails, it reroutes the traffic only to the healthy instances. And even then, it keeps monitoring the unhealthy instances. So in case you go and fix that, whatever is wrong with that unhealthy instance, and once it determines the instance is back up and running, then the load balancer will start sending traffic to the healthy instances. So it basically, load balancer allows us to distribute the traffic among multiple instances. It enables to design fault-tolerant applications. It detects unhealthy instances and does not send traffic to those unhealthy instances. And then once the instances are back up and running, then the traffic is sent to those instances. And as a best practice, we want to spread out our instances across multiple availability zones rather than putting all our instances in a single availability zone. So some of the availability concerns that we can address is EC2 SLA is 99.95% availability is guaranteed, or SLA is guaranteed by AWS. If you want to increase the availability even more, we should launch our instances in 2 or more AZs, like we said in the previous slide. Okay. And so this eliminates any kind of single point of failure in your application. By launching our application in multiple AZs, we are protecting our application from any single point of failure, any kind of failure that might occur in our application. When you want to talk to our EC2 instances, one of the things that we need to set up, the first thing we need to set up is what's called a key pair, or SSH key pair. This is essentially uses public key cryptography to encrypt and decrypt our login information. So like the name suggests, there are two key pairs. There's a public key and a private key. So AWS inserts that public key portion into the virtual machine at launch. Okay, and the private key is in our possession. It's only on our laptop. We download this private key the first time we create this SSH key or key pair, and the public key is inserted into the VM at launch. And you need that key pair before you can connect to the instance. The first time you want to connect, at least you need to have the private key to connect to that instance. The next security control that we want to talk about is called security group. Security group is nothing but a virtual firewall. It allows us to control what type of traffic we want to allow to access our instances. We can specify which port is allowed, which IP addresses are allowed to interact with our instances. So when you launch an instance, Amazon asks you for this security group, or it assumes a default security group. And security groups are essentially a group of rules. We can add as many rules as we want to our security group that allow us to control traffic from other instances or from the internet. At any time, you can modify the rules of the security group. You can add more rules, or you can delete rules, and then those rules take into effect immediately for all the instances that are using the security group. So here's a list of security groups in our application. So this is a sample application. I have 3 web servers here. I have a web server, I have a database server, and I have an application server. And the red ring around it is the security groups, or the firewalls that AWS provides us in our account. So as you can see from this diagram, I have allowed port 80, which is my web traffic, and port 443, the secure HTTPS traffic, to allow to talk to the web server. So anybody from the internet can access this web server. And the web server, between the web server and the application server, there's also an implicit security group. And that security group allows only port 22, which is the SSH port, and the 2048, which is the application server port. So that's the only allowed communication between the web security group and the application security groups. Between the web server groups and the database security group, so it is only SSH is allowed. So you cannot directly access the database servers from the internet using SSH. You first need to log into the web servers, and from there you can SSH to the database server. The application server are allowed to communicate over port 3306, which is the database port, to talk to the databases. So this is the only way all this communication flow between each of these layers of the services is configured. And from the internet, or from a specific IP address range from the internet, we are allowing port 22, or the SSH port, to talk to the web security group. So the next topic we want to talk about is Virtual Private Cloud, or VPC. So VPC allows us to logically create a logically isolated section in the AWS cloud. We have complete control over the range of the IP addresses that we want to use. We can create one or more subnets in the VPC. We can create routing rules. We can create the network gateways. So essentially we have complete control over this section of the public cloud. Okay. And the other benefit is we can extend or connect our corporate data center into AWS. Okay. So in case there is we call this an extension of our data center. So we can securely connect our corporate data center with AWS as long as we are using Virtual Private Cloud, or VPC. Want to talk about is how do we monitor our EC2 instances. There are several ways we can monitor EC2 instances, but we'll talk about the default way, or the service that's provided by AWS. By default, AWS can monitor our CPU utilization. It can monitor the number of disk reads, the disk writes, the network input, how much packets are coming into a network, how much packets are leaving our network, and if there is a system check, that AWS constantly monitors the health of our instance. All those parameters can be captured or monitored using this service called CloudWatch. Okay. It's it's a service that we can use to monitor all these resources. And by default, CloudWatch monitors using a 5-minute granularity. All these metrics that we talked about is monitored using 5-minute granularity. If you want even more granular monitoring, you can enable what's called a detailed monitoring. And when you enable detailed monitoring, there is an additional charge that may apply to your account. Okay. When you create a new account in AWS, AWS provides what's called a free tier for your application, for your account. So they allow you to have 750 hours per month of either Linux operating system, Red Hat operating system, or a SUSE Linux machine, as long as you're using a T2 micro instance. They also allow you can also include a Windows machine, a Windows instance in your account. You can run all those instances at one time, or you can use them simultaneously. So obviously, if you are using one machine at a time, that's approximately 750 hours in a month. And if you're running multiple instances, you won't be able to run them for the entire month. So we talked about the pricing in the previous section, and the pricing is essentially based on the type of the instance you're using and which method you use to purchase those instances. So we talked about 3 different types of pricing options: the on-demand pricing option, the reserved instance pricing option, and the spot instance pricing option. We'll talk about this in detail in the next section. If you need additional pricing, if you need to get the latest pricing of any of those EC2 instances, you can visit this URL. So if you look at this slide, the orange dotted line over here is the Amazon's capacity that they have in the data center. And this sine curve, the curve here that you're seeing, is the on-demand instances. People are spinning up new instances, and then when they're done, they're shutting down those instances, and the cycle keeps going. So during the week, during the business hours, as you can see, the demand is very high, and at night the demand kind of slows down. So this is the curve. The black line that we see here is the on-demand pricing, and the reserved instances are those blue shaded section that you see here. So that means people have paid the down payment. They have reserved this capacity for their use because they know the capacity that they're going to use. So Amazon has reserved that capacity for people who have paid for that capacity, and they guarantee that capacity for those users. So the difference that you see on this slide between this blue shaded area and the capacity that they have is an excess capacity. Sometimes it's overused, and sometimes it's underused. Okay. Pricing that you are given if you're not purchased the reserved instance pricing, or if you're not chose to use the spot instance pricing. This tends to be the most expensive option because you are starting and stopping your instances when you want, and when you're done, you're just terminating it. So that means you don't have any long-term commitments. And since Amazon is not able to figure out how much demand they're going to have, so they are taking a lot more risk. So that's the reason they'll charge you little bit more money when you're using on-demand pricing. The pricing vary by region. So in some of the regions, the pricing may be a little more expensive because there's a lot more demand to that, or there's a lot more, the AWS may be paying more money to use those data centers. And you are billed on an hourly basis. Even if you use for 20 minutes, they round it off to the nearest hour, and you are billed for the entire duration. The other thing you want to remember is if you stop and start the instances within the same hour, you will be billed twice, because you start the instances at, let's say, 5 after, and then you use that instance for 15 minutes, then you might stop for the next 10 minutes, and if you start it again, so you'll be billed for 2 hours. The price typically includes the price of the operating system itself. So even if you're using Red Hat, Linux, or Windows, the price they quote you includes the license cost also. The reserved instance, on the other hand, tends to be very less expensive than the on-demand pricing. So you would be paying 25 to 40% below the on-demand pricing. The downside is it requires a commitment and signing up as some sort of contract. Because of this contract, you are offered a lower hourly rate for your use. So this down payment is called an upfront cost that you need to pay to your AWS account. So like the on-demand pricing, it includes the cost of the operating system. And if you have purchased additional or excess reserved instance capacity, you can sell it in the AWS marketplace. So if you're not using that reserved instance capacity that you purchased, you can just sell it. Benefit of going with reserved instances. So if you don't do any reserved instance pricing, if you don't do any purchase any reserved instances, the hourly rate for an M3 medium is about 7 cents an hour. Okay. If you do go with the reserved instance 1 year term, if you do the upfront payment of $372 for the instance, your effective rate drops to around 4.3 cents per hour. Okay. So like we said in the previous slide, you're saving about 40% over this cost. If you do a 3-year contract, on the other hand, and if you put down a higher upfront cost, for the same instance you'll be paying about 2.5 cents. So this is saving about 63 cents over the on-demand pricing. So that's the benefit of using reserved instances. So you're paying a combination of the upfront cost and a lower hourly cost to enable you to save around 63% over the on-demand pricing. If you need to know how much it's going to cost you based on the region that you are looking for, the instance type you're looking for, the operating system that you are looking for, you can go to this site called cdn.awsnow.info and put in your information here, and then it breaks down it into the reservation period, whether you're using for the entire year or whether you're stopping it for a partial year. They'll tell you your on-demand pricing, and then the reserved instance pricing are also broken down by how long you're going to use, whether it's a light utilization, whether it's a medium utilization, or it's a heavy utilization. So this is a good site to bookmark it if you want to look at the pricing information for your EC2 instances. The last type of instance we want to talk about is the spot instances. So remember, we looked at the chart previously where they had excess capacity between the reserved instances and after all the on-demand pricing requirements are met. So what AWS does is they already have over provisioned capacity, so they want to auction off the unused capacity, and then you in turn can bid for that excess capacity for a very low rate. And as long as your bid is the highest, then you'll get that capacity. You can use it for your any kind of back-end processing that you're interested in doing, and when you're done, you can either terminate them, or if somebody comes along and outbids you, then you'll be kicked out. So that's the risk you're assuming by going to spot instances. But there are a lot of use cases for using those capacity, as long as you don't care, when your job gets done. So you can keep on looking for a lower spot instance pricing that saves you money rather than using on-demand pricing. The couple of ways of using or starting instances in AWS, obviously you can use the AWS Management Console like we talked about. You can use the CLI command line tool, and it requires the Python program on your machine, and you need to download the CLI from AWS. You need to have the API credentials to start or stop or terminate any of the resources that you want in AWS. The other option is to use REST API to basically program in any of these languages like Java, Python, C#, .NET, and so on. So assuming we are going to use the AWS console, we essentially go to this URL https console.aws.amazon.com/ec2, and on the dashboard there's a button to launch an instance, and we then choose the Amazon machine image or the operating system we want. We choose the instance type we want, whether we want a small instance, large instance, extra large, or all the instance types that we discussed in the previous section. And we mention how many instances we want. The default is the launch one instance, but you can choose to start additional instances. And then you choose where you want that instance to be started, which private cloud, which VPC that you want to start that instance. The default is okay for in our case, but if you have more than one virtual private cloud, we have to choose which VPC our instance should be launched. So that's the first screen they'll ask you. The second screen is once you choose the VPC, you might have additional subnets. You might have more than one subnet. So in that case, you may have to select which AZ or which subnet your instance should be launched into. Then they'll ask you how much storage you need for your instance. So you have two options here. One is the storage for your operating system itself, how much storage you want for your OS, plus any additional storage that you want for your data or your application. You can choose on this screen. Then you can tag the instance for easily identifying it. So if you have a large account, if you have multiple instances, you need the ability to tag or identify the instance that you launched. So you can give a friendly name to your instance so that when you look at this console, you can identify the instance that you just launched. They'll ask you for the security group. Like we said, this is the default security group that you can choose, or you can choose to create a new security group. Okay. And then by default, you would want to use SSH turned on for our lab exercises when we look at, so that we can SSH or log into our instances. Then the last thing they'll ask you to choose is the key pair. How do you want to access this instances? If you already have an existing key pair, you can choose it. If you don't have a key pair, they'll ask you to create a brand new one, and then they'll let you save the private key file on your laptop. So this is the only time you have the option of saving that private key. So Amazon retains the public key portion of it. The private keys allow you to download only once to your laptop. Then finally you just launch the instance, and it takes a few minutes to launch it. Once the instance is launched, we use the SSH client to access the instance. So Mac and Linux machines have the built-in SSH client, so we can use that client to log into our instances. For Windows, we need to use the PuTTY program or any other SSH client that you might have. But if you are using PuTTY, you need to download PuTTY and also the PuTTyGen tool. PuTTyGen is part of the PuTTY, or you can find it on the same website. But the PuTTyGen is essentially used to extract the private key from this PEM format that Amazon provides into what's called a PPK format that the PuTTY program understands. So PuTTyGen is typically used just the first time to convert the .pem file into .ppk file. And once you convert that, there's no need to have PuTTyGen around. Yeah. And once you have the key converted, then you can use the PuTTY program with that ppk file that you generated to SSH into your EC2 instance. If you have a Windows instance instead of a Linux machine, a Linux EC2 instance, you can use the RDP client or the remote desktop client to connect to the Windows instance. So in summary, we talked about the performance enhancements that we can use for our EC2 instances, the different types of instances we can select based on our application requirement. We learned about the different scalability options in AWS, how to scale vertically, how to scale horizontally, and how to, we learned a little bit about auto scaling. We learned a little bit about elastic load balancing. We learned about availability of our EC2 instances and the SLAs they guarantee us, there is 99.95 availability. We learned about SSH key pairs, we learned about security groups, and we learned about VPC as the security mechanisms. And we learned about the monitoring aspects. We learned how we can monitor for our CPU utilization, the disk read writes, the network bandwidth, the network usage, and the system checks that AWS provides. And finally, we learned about the costing model or the pricing model. In that, we learned about the on-demand pricing, the reserved instance pricing, and the spot instance pricing. Next, we learned how we interact or interface with our EC2 service using the AWS console or the command line or the REST API.